a terrestrial exoplanet orbiting in the habitable zone of the nearest star Proxima Centauri has just been discovered, and named as Proxima b. It has a size of about 1.3 times our planet, and an orbital period of about 11.2 Earth days. Now let's talk about the host star first. The star Proxima Centauri is part of a triple star system, Alpha Centauri, which consists of two solar-type stars, Alpha Centauri A and Alpha Centauri B, separated by about 20 astronomical units. 1 astronomical unit equals distance from Earth to Sun. And a distant red dwarf, Proxima Centauri, is 15,000 astronomical units from the other two, which is currently the closest star to the Sun, at about 4.24 light-years away. Proxima Centauri is a red dwarf. It has only 12% mass of the Sun, and its brightness is only 0.15% of that of our star. The planet, called Proxima b, is at least 1.3 times the size of Earth, and completes one orbit in 11.2 Earth days. The planet is just about 7.5 million kilometers away from its host star. By comparison, the Earth is at approximately 150 million kilometers far from our Sun. This may seem very close, but because of the low brightness of the star, the planet receives only 65 to 70% of the radiation flux that the Earth receives from the Sun. The real mass of the planet depends on the geometry of the orbit, which is not known yet. The most likely mass is 1.4 times of Earth mass, which makes it probably a rocky planet. While Proxima b is today in the so-called habitable zone of its star, where surface oceans may exist, it has not always been the case. Its star has evolved differently from solar-type stars, and its brightness has decreased over time. Early in its history, the planet received a much greater flux of energy. During the warm phase, water was vaporized into a thick atmosphere which was exposed to high-energy radiation from its star. Proxima Centauri, like most red dwarfs, is very active, and the planet is exposed to more X-ray and extreme UV radiation than Earth. The combination of these two factors, vaporization of the water and strong exposure to high-energy radiation, generates evaporation of the water content from the atmosphere to space. The purpose of the research was to estimate the atmospheric losses, and to determine whether the water reservoir in the atmosphere could survive this early hot phase. The fate of Proxima b depends on the amount of water and gas the planet inherited during its formation, which was very different from that of the Earth. We do not know if Proxima b began its history with more or less water than Earth, and the planet could still possess a thick atmosphere and oceans despite early atmospheric losses. Due to the short orbital distance of Proxima b, strong tidal forces exerted by the star allow only two possible rotations for the planet. In the first case, the planet is synchronous. Its rotation period is equal to its orbital period, and it always presents the same face to its star. In the second case, called asynchronous, the planet rotates 3 times every 2 orbits, like Mercury. A situation that can arise if the orbit is slightly eccentric, which is possible but not yet determined. In both cases, Proxima b should not have seasons, because tidal forces cancel the obliquity, bringing the equator on the planet's orbital plane. Depending on the rotation period, and the amount of greenhouse gases, water may be present over the surface of the planet, only in the sunniest regions. That is to say, in the area facing permanently the star, in the synchronous case, and in a tropical belt, in the asynchronous case. Although Proxima b is an excellent candidate planet, that could harbor life, but it cannot be considered an Earth twin. In fact, the history of Proxima b and its star was radically different from the history of the Earth and the Sun. Presently, we don't have any confirmation about life on Proxima b, but sooner we will find out if it has any, because researchers already proposed various missions for it, which we will tell you about in the upcoming videos. So, that's all for this video.
Thanks for watching.